Welcome to Ask and Learn.
So we're given the potential difference, delta V0, between plates on an air-filled capacitor is 85 volts. And the same potential, or the different potential difference on the same capacitor once we insert a dielectric is 25 volts. And each of these capacitors have their own capacitance. For the first one, it's just going to be epsilon naught A over D. And the second one, we need a dielectric constant, so kappa times epsilon naught A over D. Now, delta V0, we can relate that to the capacitance. That's just Q over C0, which is Q over epsilon naught A over D. So this comes out to Q times D over epsilon naught A. And delta V is Q over C. And the Q is the same for both because we have the same charge. It's not going to change. So this is Q over kappa epsilon naught A over D, which comes out to Q D over kappa epsilon naught A. And now I can solve for kappa over here. So kappa, remember this is delta V. This is going to equal 1 over delta V times Q D over epsilon naught A. And this is just what we have over here, delta V0. So kappa is going to be delta V0 over delta V, which is 85 volts divided by 25 volts, and that's 3.4. Now 3.4 is about the same as the dielectric constant for nylon, so we could predict that the dielectric in this problem is nylon. Now if the capacitor weren't totally filled with the dielectric, then, well, the constant wouldn't be quite as large as it was for nylon because part of it would be filled with air and part of it would be filled with nylon. So if this kappa weren't quite as high, then that would mean that in order to make this lower, we need to increase the delta V. So the potential difference of the capacitor, if it weren't completely filled, would probably be a little bit higher than 25 volts. Depends on how much of it was filled with the dielectric or not, but it would be somewhere between 25 and 85 volts.